the first four, if you didn't watch the introduction one and you don't know what Reeborg is, you'll probably want to go back and watch those. If you have done these or you have some experience with Reeborg and you know what we're doing, then we're going to do, oh, let's do a round one. Let's just do all of the rounds. Should we do all the rounds? Or should we just do like to a round apple? So many choices. Let's see how it goes, okay? And we're going to use Blockly again, and we're just going to go from a round one. Let's just start here. As you've probably figured out with Reeborg, it starts to build on itself. So it tries to teach you a concept, and then it sort of adds, it makes that concept more difficult. And you can find out what it's trying to make you do by clicking on this world info button. And as you zoom in here, you'll find, how do I zoom in? Oh, I don't know. I'm sure I feel, oh, there we go. You have Reeborg go around the world in a counterclockwise direction once and stop at its starting position. Reeborg must not step on grass. The correct path is shown by a dashed white line. So this is what you're going to need is move, turn left, and put. You actually don't need put to accomplish this one. And then it's going to say you can write a more general program, have it decide yourself where it comes back to its starting point. But that really happens automatically on when you go to the next ones. So when you go to a round one variable. So really simply, if we're just going to use what we learned from home 1 through 4, we know that we move 10, or sorry, we move 9 because there's 10 and we start on 1. So we move 9, we turn left, 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 and we're there. So let's just keep this one as simple as possible. And I know that I'm going to repeat this whole thing 4 times because there's 4 sides in this square. I know I'm going to make a loop of 9 times because I'm going to move 9 times like that. And then I'm going to turn left, kind of like that. And I think, it's a first guess, that might work. That might actually work. Let's play it, and let's see if our Reeborg robot can get there. And it does. Well done. Congratulations. That is a round one. Now, that's probably the simplest way to think of loops and how to get back the quickest. You'll see it actually starts to get more difficult where this thinking doesn't work as well, but at least it gets us started, okay? So let's go to a round 2 now. This one's variable. Now, if you read the world info, you'll see that every time you refresh this screen, so every time I start this, and then I stop it, and then I refresh it, the size of the map changes. Well, so we can't really say repeat. We can repeat 4 times because it's always going to be a square or a rectangle, but it's not necessarily going to be 9. And this one might be 2 or 3, and this one might be 10, or up to 9, I guess. The other problem we have is it always kind of starts in a different place. So you'll notice they put your Reeborg in a random place every time. Is it always right there? There's no way. Yeah, so this time it's 5 or whatever, number 4 away. Sometimes it's 3 away. So when we come back around, we actually don't know where to stop. And really we have to do it 5 times because I don't think we ever start in the corner. So it's really 1, 2, 3, 4, and then 5. You sort of have to do the last half to connect. Well, luckily, if you read the notes really close, you'll see this put thing right here. And then I think there's a hint on here. Yeah, here's the hint. It says Reeborg carries some tokens. You only need to use 1 token. So you think about that for a second, and you're like, well, why do I need a token? Well, really what happens is if you hover your mouse over your Reeborg person, robot, you'll see this number 500 with a smiley face. That actually represents a token that you have that you can put down. And so the trick is if you come to basic commands and you really just do put and then move. I'm gonna trash all that stuff because that doesn't really work here. But I'm just gonna press play and I just want to see what happens. So look, it puts down this coin. And now, when we use our conditionals over here, we can find an object here eventually. So we basically want to walk around in a circle until we find that coin is on the ground, right? And of course, it says Reeborg did not follow the required path, of course, because we didn't get it right. But we're on to something here with putting a coin down and moving off of it. And now, we really want to just start walking around until we find the coin. And we got to create some logic, some brain inside of Reeborg to do that. And really, if you've done it enough and you've thought about it long enough, really Reeborg needs to do, there's really one decision it needs to make. It is there a wall in front of me? If there is a wall in front of Reeborg, then it needs to take a left, right? If there's a wall, it takes a left. If there's a wall, it takes a left. If there's not a wall in front of Reeborg, then it moves. So if you come to these conditions, right, or excuse me, decisions, And really look at this. So if conditions, wall in front, turn left. Else meaning it is not true. So if this is true, if there is a wall in front, turn left. Else if it's not true, then what do you want me to do? Well, I want you to move. And I want you to do that. And I want you to do that. And so let's play this and let's see what happens. So it's going to put, so it put down a coin. It took a step. And then it said, okay, if there's a wall in front, turn left. Well, there's not a wall in front, therefore move. Well, the problem is that Reeborg did not follow the required path because it needs to keep asking itself that question, right? How long do I need to do this for? Well, it needs to do it until when? How long does it need to do it? Well, with a variable map, it needs to keep doing that until it's at a coin, right? So after it puts and moves, it really needs to make this sort of looping type decision that until there is a coin on the ground, it really needs to do this. So repeat until object here. That you need to make that decision, Reeborg, until there is a coin on the ground. And then once there's a coin on the ground, you can be done. Now, you don't have to put done here. You can if it makes you feel better, but you don't have to put done because once it stops, it sort of reads where it is. You don't have to tell it it's done if, in fact, it is done. Sometimes we do use this in the code to sort of force it to stop, and I'm not sure which way I like it better. I kind of just keep it off, but you're welcome to put it there if it makes you feel like it's better. So let's just see if this works. So it takes a step. Ooh, there's a wall there. I turn left, and it keeps doing this. I'll even pause it for us, and then I'll speed it up. And then this is the part that's slightly interesting, I guess, if any of it is. And so it's going to take a step. So it's right here, and it says, is there a wall in front? The answer is no. Then what do? I move. So it moves. Oh, I press this button. It moves, okay? And then it repeats until object here. It sees that there's an object on the ground, and it should stop and tell us that we finished. And lo and behold, it has stopped and said, well done, you are finished. Got it? So there's the code for the around one variable. And I hope you can sort of see how it's starting to, we feed this thing logic in a loop with a big condition over it, and really that's how it works. That's how it works. And we do that over and over again. Pretty fun. Okay, so let's do the next one. Around one apple. So this one, notice it's at a house. We could read this here. And it says, Reeborg must go around the world collecting all the apples so he can make apple pies when he gets home. Try to make the code as short as possible using for and repeat loops. Beware, the apples keep changing place each time you reload the world. Okay, so as you know, we're trying to make the code short. We're trying to make it concise, make it readable. And I should also point out, when we code in real life, we're not necessarily always trying to make stuff the shortest, code the shortest. We're trying to make it the most obvious. I think good code is written that anyone can look at it and be like, oh yeah, I kind of see what's going on. And you can get in there and fix it. And the little functions and modules and questions are like obvious. That's what I think is super helpful. Okay. Anyways, you notice here that the house is here, and every time you restart this, I wish they would have done this and made it variable, because I feel like around one variable might even be more difficult than this, because this one, you just do it 4 times. You just move 4 times, and you could change this repeat 4 times. You could just repeat, so you could choose this loop, repeat it 4 times, because it always starts right here, and you're always going to end right there. So you could do it that way, but I'm going to do it this way, where I take this thing off, and I actually at goal. So repeat until at goal, and so then whenever it gets back to the house, it's good to go. We also don't need this whole put move thing, but we do need the move, because it's going to ask itself the very first question, is it at the goal? And it's going to be at the house, and it's going to stop and say, hey, you haven't got the apples. Reeborg's like, well, you told me to stop when I got to my goal, and I was at my goal when I started. So you got to sort of force it off of that block, and then you can run this game. And really, so you got to think, what is the question Reeborg is asking? And it says, if there's a wall in front, correct, turn left. Else, move. That's still true as today as it was last time, right? But there's another piece, is that Reeborg has to pick up the apples. And there's a few ways to add this sort of conditional statement inside of it. But if you just go right here and you grab an if box and you grab object here and a take, and you sneak that on top of that right there, that honestly should work. Now, there's also this one that's called if, else. And you could try that one too if you want to goof around and see how that one works, and I think you'll have some success. But you can also just do it just like this. If there's an object here, great, and then it runs through this code right here, and you will see rather quickly that it is working very well, just like we always hoped it would. Notice that there's 214 steps that Reeborg has to do, and then it sort of walks through this again. I can pause this guy, and I can run it, and it's going to come back here, and it's going to get to the goal. So let's just sort of think about this. It takes a step. It picks up the last apple, and then it says, okay, repeat until that goal, and now it's at the goal, and it should give us, good job, you did it. You have finished apple. And there you go. That's the code for apple. Let's do the next one. We haven't done very much here. Okay, this one is also kind of interesting. This is actually more like the variable one than the apple one. So we have to put a coin down. So we're going to grab this basic command. We're going to put and move. We just know that's always the case. And then we're going to do this not until at goal, but until object is here. So we're going to do something in here while the object is here. And I probably shouldn't have deleted that stuff in the middle, but let's just start fresh. So we know we're going to put a coin. We're going to step. And it's back to that original decision, right? Which is if there's a wall in front, so if there is a wall in front, then we want him to turn left, and otherwise just move. So let's run this, and you'll see the problem really quickly. The problem is we're going to get to right here, okay? And Reeborg is looking here, and it's going to ask this question, which is there an object here? There is not, okay? Is there a wall in front? There is not. So therefore, what's it going to do? Well, it's going to move. And we don't want it to move, though. Problem, right? Now it does the box again. And we don't want it to do the box. We need it to do the entire sort of this L shape, right? So it's going to get back to here, and it's going to stop, and it's going to say, you did not follow the required path. Well, we have to give it some more logic now that says, wait a second, if there is no wall on the right, then I need you to turn right. So if you remember back from the previous video, first thing we have to do is probably make a little function, a to-do defining box that we are going to call turn right. And you turn right by turning left 3 times. And the way I like to make that is to put that like that, like that, like that. Okay? So we have this turn right function that we can call on whenever we want. But we also need to ask, again, we need to ask it just another question. And I'm going to try it like this, and let's just see what happens. And I might not get it right the first try. But if there is, and you can click here, really if there's not a wall on right? So I can grab this, see this not button right there? Pop that in there, pop that in. So if there's not a wall on the right, then I want you to turn right. And every time it turns right, it has to move right after that, because I want it to sort of get out of this decision loop. Turn right. I don't want it to turn right and just do a circle, because there's never a right. Turn right and move. Okay? Let's try that, and let's see if that works. And hopefully that makes sense. If there's no wall on right, turn right and move. Otherwise, check. Is there a wall in front? Great, turn left. If not, move. And keep doing all that till there's an object here, and we put that object here to start, and we define what it means to turn right, which is really to turn left 3 times. We press play, I press pause, and you see I put a coin down. There we go. I snag this, and this is sort of the decision, right? And you saw that it worked, but it gets to this point, and it says, okay, is there a wall on the right? There is not a wall on the right. Okay, then it runs this code inside of this conditional statement, and you can pause it, and you can run it out. And you did it. Yes. Worked great. Worked wonderful. You also could have done it with this one here. In fact, let's do that really quick just to show you, because you're going to like these if-else boxes. They get even cleaner than this. Else if, you can put multiple conditions in here. And in the end, if none of that works, just move. So this allows you to check for one condition, and if this condition is not true, then well, let's check for this condition if this one's not true. And then if neither of these are true, just do whatever is left down here. And I believe, unless I lose my mind, I think this one also works just great. And there it is. It worked great. So either way, as you can see, it works fine. Okay, let's do a round 3. Since we're on a roll, let's get the arounds done here. World info. This is a round 3. We want to go around in a clockwise direction. We already knew that. We stop it at starting position. So we're going to use that little coin thing again. Your program should also work for a round 1 and a round 2. So that gets a little trickier that we want to go back and make sure that it works for a round 1 and a round 2. Here's a bunch of functions you can use. And, we're starting to get hard. This is a little more difficult than, home, where we just had to move 2 times forward, right? Okay, this one, let's see what happens right here, by the way. So if there's not a wall on the right, it turns right and moves. If there's a wall in the front, turn left. I mean, honestly, this might work. Let's think about that, because if there's a wall in front, so it's going to ask, is there not a wall on the right? No, there is a wall on the right. Okay. Is there a wall in front? There is indeed a wall in the front. Okay, then turn left. And then it will loop back through this, and we'll do it again. So let's try to see if we can't surprise ourselves. Ooh, it hit a wall. Now, why did it hit a wall? That's because right here, it has this problem. And the problem is that it tried to put and it tried to move, right? So our problem is that we have to think about this put, and we can't do it like this either. And why not? Well, let's press play, and you'll see why. It puts it down, and then it's done. But it's like, no, it's not done, because it put it, and then it found that there's an object here. And it's like, oh, wait a second. I need you to move off of this, and then I need you to put down the coin, right? Like, I need you to put on the coin and move off, and then start running this sort of brilliant thing. So let's think about this a little bit differently, and you'll see maybe where I'm going here in the beginning, which is this. So if there is a wall in front, I'm going to try it this way. I've honestly never tried it this way before, but why not? Just play along. If there's a wall in front, I want it to turn left, okay? And I want basically it to do this until it can turn left until there's an opening. So if it turns left and it sees that there's no opening, and you'll see why this is when I do a round 4 here in a second. But if there's a wall in front, I want it to turn left. But I really want to do this until the wall is no longer in front. So I'm actually going to grab myself a loop, and I'm going to say while there's a wall in front, turn left. I'm going to take this off, and then I'm going to put this here, and I'm going to grab a move box. I'm going to put that there. So now I'm saying while there's a wall in front, I want you to turn left. And then once there's no longer a wall in front, then I want you to put and move so we don't have this problem where I'm running into this wall, right? Hopefully that makes some sense. If not, again, lots of ways to do that, lots of ways to think through this. Unfortunately for my brain, I've done the ones that are coming also, and so it forces me to sort of think through the real problem that you'll see here in a second. But let's try this, and let's see 235 moves, so that's a good sign. And see how that worked great? And now it's just asking its question. If it's forward, and is there a wall on the right? Nope. Take a step. See, that's pretty complicated, but it's going to do it just great, right? And we know the rest of this worked because now it's just in this loop right here, and we've already seen it work there. All we just got to make sure that it stops on that coin, and indeed it stops on that coin. Well done. So it's sort of getting out of this maze issue right here, and that's how you do a round 3. Okay, so ready? Watch this. A round 4. If you notice, oh wow, it's like trapping you in here. And so, but it turns out our logic for a round 3 works for this one, because it's just going to check, is there a wall in front? If there's a wall in front, turn left, and it's going to keep turning left until it finally has a clear path. Then it puts, then it moves. So let's try it here for a round 4. Oh, and it turns, and then there we go. And it made itself out of its little hole, and then it just walks through here, and it checks if there's no wall on the right. It's going to turn right, and there you go. Got it. And that, my friends, is how you do a round 4. Okay, hopefully that's starting to make sense. I just hope if you're coding along, you're not just forwarding along to like the part where the code works and then pausing it and then just copying it, because the point here is to learn it. The point isn't to, if you're doing creative coding, it's not creative copying. The point is for you to try to figure it out. You sort of work through these problems in your head. And then if you get stuck, you can fast forward and see how I did it. And then maybe reverse engineer it and sort of walk back and see, well, what happens if it says until? Like, does that work? And what happens if I do something else here? What happens if I change this up? Anyways, I hope you're willing to do that, because otherwise, to be honest with you, you're just wasting your own time. Like, what's the point other than just trying to make copies of stuff? Like, we're trying to learn how to code. You're trying to make your brain think through this stuff. And all this stuff seems silly, by the way, in terms of like real life coding. I promise you, talk to anybody who knows how to code. And this sense of like getting this procedural programming down, how steps work, how loops work, how things have to happen in a certain order, how you have conditions, how you have conditionals, so you're asking questions and you're making little functions and you're plugging those functions in. I'm telling you, that is real coding. That is all that coding really is, just maybe with different kinds of concepts besides a little robot walking around a map. All right, there's my speech.